This week we're going to work with adding fractions, and we're going to work with fractions that have common denominators. Common denominators mean that the bottom number are the same for both fractions, or sometimes there might be more than two fractions, but all the fractions have the same bottom number, which means the whole was broken up into the same number of parts. There's a couple of rules that when you are adding fractions, every time you add them, the denominators must be the same. They have to be the same in order to be adding fractions. And then the other rule is that the denominator stays the same in the sum. And we know that the sum is the answer to an addition problem. So when you bring over your fraction into the sum, into the answer, it has to stay the same. We're going to look at this with a couple of examples. So the first example here I have is 3/6 plus 2/6. So the first thing you notice is that the denominators are the same in both of these add-ins. So I'm just going to bring the 6th over to my sum, to my answer. Once you do that, all you have to do is focus on the top two numbers. You just have to look at the numerators and add 3 plus 2. 3 plus 2 is 5. Now the denominator does not change because when you look into this model, you see that this model was originally broken up into 6 parts. That's what the denominator tells us. We have 3 parts, and we're putting it together with the other 2 parts, which gave us 5 out of 6 parts. So our sum, our answer is 5/6. We're going to look at one more example with adding with common denominators here. We have eighths this time. We have 4/8 and 3/8. And again, we're looking at the denominator. The denominator is 8. It's going to remain 8 in the sum. Now, once you have the common denominator, all you need to do is look at your numerators. And you're only adding 4 plus 3. 4. And in fact, if the denominators get a little bit confusing for you, when fractions get confusing, just cover up the denominators when you're looking at it and think, okay, what's 4 plus 3? 4 plus 3 is 7. So you're going to write that in the sum in the numerator. And again, you can see that the whole was originally broken up into 8 equal parts. When we have 4 and 3 together, we have 7 out of 8 parts. So the denominator is not changing. The denominator is remaining the same. Now sometimes when you're adding your fractions, you're going to come to a situation where the sum, the answer, is going to be what is commonly known as an improper fraction. So we're going to take a look at an example of that using models. So we have 3/4, and we're adding 2/4 to that. Now again, we have common denominators here. We have the number 4. The original whole was broken up into 4 equal parts. And I'm going to bring the 4 right over to my sum. The next thing I'm going to do is I'm going to look at the numerators. And again, you can cover up the denominators and just add your numerators. 3 plus 2 equals 5. Now, this looks a little unusual because we're not used to having a numerator greater than a denominator. But let's think about if you had 2 different, maybe pizzas, cut up into 4 slices each. And this was the pepperoni pizza, this was the cheese pizza. When you go to clean up at the end of the night, sometimes you'll put the pizzas together to make a whole pizza. So if you took 1 slice out of this box and put it in the other one, you would have 4 parts. That would make 1 whole pizza. But you still have 1 part left out of the box. You'd have to wrap it in tin foil, whatever, but it does not fit in the box. So you would have 1 whole and 1/4 left over. When you look at 5/4 and you think of a whole, break this down into the number of wholes in there. 5/4 has a 4/4 in it and a 1/4, right? Because 4/4 plus 1/4 equals 5/4. This is your whole right here. This makes 1. Anytime you have a numerator and a denominator that are the same, that is 1 whole. So here you have your mixed number, 1 and 1/4. We're going to take another example of this because it can be a little tricky. I'm going to just take a moment and erase my 6th up here. And we're going to work with the 5/6 we have set up here plus 3/6. Now remember, again, you're combining two items that were broken up into 6 equal parts to begin with. So I have 5/6 and I'm adding 3/6 to that. Now, when I'm adding, again, the first thing I do is I look at my denominators. I have 6, so I'm bringing it right over into my sum. The next thing I do, I'm going to add my numerators. Again, cover the denominators if it's confusing. 5 plus 3 is 8. When I'm putting these together, and I have 8/6, which is a little unusual, I have to think about how many parts are in the whole. So there are 6 parts in the whole, 1, 2, 3, 4, 5, 6. So that is my whole. I have 1 whole, and I have 2 parts that do not fit into that whole. So I have 1 whole and 2/6 left over. Again, if I were to take 8/6 and break it down, 6/6 is equal to 1. Plus, I need to think about 6 plus what equals 8, and that would be 2/6. So 1 whole and 2/6. That's where I get my whole number, my mixed number.